All right, so we're going to do a slight little bit of review today. We're going to talk again about terms and factors. Okay. And terms are things we add. So if you're taking notes, and you should be, let's go ahead and write these down again. Terms are things we add. Factors are things we multiply. And I told you before that we were going to look at the definition. Terms are things we add or subtract, and factors are things we multiply or divide. And we're going to shorten that to things we add and things we multiply. And to show you that, write down in your notes the definition of subtraction. Okay, the definition of subtraction. What is the definition of subtraction? The definition of subtraction, A minus B, is defined by A plus negative B. Okay? And because of the reflexive property that we go over in geometry, not necessarily algebra, but it's one and the same, the reflexive property says I can switch the left side of the equation to the right and vice versa. You can also look at this as A plus the opposite of B is equal to A minus B. Okay, put that in your notes. And the reason is because the definition of subtraction shows us that subtraction is really just a special case of addition. Okay, when we add things together, we can add negative things, and we shorten that by saying A minus B, right? So if I have 12 Twinkies and I give my sister 4 of them, anybody know how many Twinkies I have left? Nobody? 8 Twinkies. I have 8 Twinkies left, right? If now the other way that I can write that is I can say that I have 12 Twinkies, but I'm going to add negative 8. I'm sorry, what did I say? Negative 4. Take away, what did I say? I don't even remember. Did I say 12 or 8? Anyway, if I have 12 Twinkies and I take away 4, that's the same thing as saying I have 12 Twinkies and I'm adding negative 4. Okay? So what that allows us to do, since we can add things in any order that we want, this comes in very handy. Because if I have a situation in which I have A minus B, I cannot subtract things in any order I want. That is not equal to B minus A. However, if I change this A minus B to addition by saying that subtraction is the same thing as A plus negative B, now I can switch it because it is addition, and I can add things in any order that I want. So if I do that, then I have negative B plus A. Okay, and this comes in very, very handy. So the same thing with factors. Okay, same thing with factors. If we look at division, let's look at the definition of division. Okay, A divided by B is A times 1 over B. Those are the same thing. And this also comes in handy so that we can, because we can multiply things in any order that we want. We cannot divide things in any order that we want. So we can change everything to multiplication and then move things around. That gets very useful for us when we're solving problems. Now we're going to look at terms and factors. Terms are things we add. Factors are things we multiply. Make sure that is in your notes. Terms are things we add. Factors are things we multiply. I will refer back to those two things quite often as we move forward in our algebra. So you want to make sure that you have that in your notes. Okay, so if I have terms, okay, I have also what are called like terms. I have like terms, okay? What are like terms? If you remember from the definition that we covered a few weeks ago, like terms are same variable, same exponent. Same variable, same exponent. Okay? So, x plus x, are those like terms? Yes. Why? Because they are the same variable and they have the same exponent. Now, any number that has no exponent on there. So let's look at the number 2 really quick. 2 to the third power. I'm going to look at 2 to the second power. I'm going to look at 2 to the first power. And I'm going to look at 2 to the 0 power. Okay? 2 to the third power. Okay, the exponent simply means how many times I'm multiplying the base. Remember, this is the base, this is the exponent, and the whole thing is the power. Okay? So this means I'm multiplying the number 2 3 times. 2 times 2 times 2. Okay, that is the number 8. 2 squared, 2 times 2. That is the number 4. What about 2 to the 1? That's just 2. So here, any number to the first power is just itself. So when you see this x right here, that's the same thing as x to the first power. X to the first power. So it's by that logic that we can confirm that they have the same exponent. They are the same variable, but they are also the same exponent. So I can combine them. X plus x is 2x. Now, does anybody happen to know what a number to the 0 power is? Message me if you think you know. Someone said 0. It is not 0. A lot of you said 0. It is not 0. One of you, two of you said 1. It's actually that. It is 1. Very good. 2 to the 0 power. Let me move my chat over here so I don't miss you guys. 2 to the 0 power. Someone asked, how in the world is that possible? All right. Well, let me show you. If I have 2 to the third power divided by 2 to the, let's say, second power, okay? The top is 2 times 2 times 2. Everybody see that? The bottom is 2 times 2. Okay. Well, the top is 8 and the bottom is 4. So what are we left with? 8 divided by 4 is 2. The other way that I can look at this is, since these are all factors in the top and factors in the bottom, remember factors are things we multiply, I can cancel out these two here, 2 and 2, cancel out these, and I'm left with 2. Okay, so 2 to the third power over 2 to the second power is 2. Now let's look at 2 to the third power over just 2. Okay, if it's just 2, we know that it has the number 1, right? So here we're going to have in the top 2 times 2 times 2. In the bottom, we're just going to have 2. So the top is 2 times 2 times 2, which is 8. The bottom is just 2. 8 divided by 2 is 4. We know that. But if we're also canceling, I'm only canceling one of my 2's on top, and I'm left with 2 times 2, which is just 4, right? Okay. Now, and we'll get into this when we look at exponents, because we'll look at them a little bit deeper. But you notice here that 2 to the third over 2 to the second, and let me write that here, 2 to the third over 2 to the second, you notice how that became 2. And 2 is just 2 to the 1. Then you notice that we had 2 to the third over just 2, that became 4. And this 2 would just be 2 to the 1. And 4, we also saw, was 2 times 2. That's where we got the 4. So we could say, okay, that's just 2 to the second. Okay, it's the same thing as 4. So notice when we have the same base that we're dividing, but we have exponents on that base, whether different or the same. I take my base 2 and I take my top exponent and I subtract the bottom exponent. So I have 2 to the 3 minus 2. 3 minus 2 is 1. 2 to the 1 is 2. Okay, now let's look at this one. 2 to the 3 minus 1. That's 2 to the 2, which is 4. Good. So when I have 2 to the third over 2 to the third, watch what happens. The top is 2 times 2 times 2. The bottom is 2 times 2 times 2. The top is 8, and the bottom is 8. 8 divided by 8 is 1. Okay, now let's look at from the exponent perspective. 2 to the third, and then I'm divided by 2 to the third. So that's 3 minus 3. 2 to the 3 minus 3 is 2 to the 0. So that's where we get that 2 to the 0 is equal to 1. Now, that was a big, long explanation, and we will definitely revisit that idea. But it's always good to get exposure and answer the question. All right, so moving on. We are dealing with like terms, same variable, same exponent. So I want you to answer. You can message me or just answer for yourself. But let's look at this. 2x plus 3x. Are those like terms? Yes or no? What do you guys think? Okay, correct. These are like terms. Same variable, same exponent. All right, so we can combine them. The 2 plus 3 gives me 5. So 2x plus 3x is 5x. All right. What about this? 2x plus 3x squared. Are those like terms? Yes or no? Okay, I've got one no. Anybody else want to take a guess? Yes or no? Someone else says yes. Someone else says yes. These are not like terms. No, they are not. Why? Well, even though they are the same base, they are not the same exponent. This exponent right here on the x is 1. This exponent is 2. So I cannot combine those. Okay? What about the numbers 4 plus 5? Are those like terms? I've got one yes. I've got two yeses. I've got a no. I've got a, someone wrote C, the Spanish for yes. 5 and 4 are like terms. They are. You can combine those. Okay, and you're thinking, for the person that said no, how are those like terms? They don't have the same variable. Yes, they do. They both have no variable. All right, since they both have no variable, that means they have the same variable. And they also have no exponent on that variable. So that can be combined. Okay, what about 3x plus 2y? Are those like terms? Can I combine those? Yes or no? Yes or no? I've got a no, I've got another no, I got three no's. I've got a no and I've got a yes, but in French. Someone's showing off their language skills to me. I've got a no with several O's. All right, the answer is no, they are not. They are not the same variable. X and Y are not the same variable, so I cannot combine those. Now, how do we know this to be true? We can know this to be true simply by using some examples. So if I use X, I'm going to use the number 5, and Y, I'm going to use the number 7. Okay? So let's look at this first one. Does 2, and I'm going to substitute in 5, does 2 times 5 plus 3 times 5, does that equal the same thing as 5 times 5? 2 times 5 is 10, plus 3 times 5 is 15. 15 plus 10, that equals 25, which is 5 times 5. So it does work there. All right, now we said no on the second one. So the first one was yes. On the second one, we said no. Let's verify that. So 2 times 5 plus 3 times 5 squared. Okay. Can I combine those two? Okay, well, I don't even know how you would combine it, because would this be 5x or would it be 5x squared? All right, 5x we know would be 25. 5x squared would be 5 times 5 squared. So 5 times 25, so that would be 125. So let's see what we have down here to see if it equals either one of these two numbers. 2 times 5 is 10, plus 3 times 5 squared. 5 squared is 25. 25 times 3 is 75. 75 plus 10 is 85. 85 is not 25 and not 125. So definitely can't combine those. We just proved that to ourselves. All right. The third one, we said yes. There's no X or Y to sub in there. We don't have to worry about that one. Now let's look at this last one. How would we combine that? Would we say 5, let's say 5xy. I've seen that from students before. 5xy, combining those two. All right, so 3 times x would be 3 times 5. My y is 7, so 2 times 7. All right, 3 times 5 is 15, plus 2 times 7 is 14. So if I combine those, I have 29. Over here, if I have 5 times 5 times 7. Well, 5 times 5 is 25. 25 times 7, wow, that's going to be 4. It's going to be 175. Is that right? 4, 8. Yeah, 8 times 5 would be 200. So 175. All right, definitely not the same answer. So we can kind of prove those concepts to each other of what we can combine and what we can't combine. All right. So here's another example for you on terms. Let's look at can I combine those? Yes or no? X cubed plus 2x squared plus 2x. Can I combine that? Somebody said no. Another person says no, no, no. You are correct. We cannot combine those. Even though they all have the same base, I can't combine any of those because they all have different exponents. Okay, so now I'm going to give you another one. All right. We have 2x cubed plus 3x squared minus 5x plus 7x squared plus 9x cubed plus 2x. Now here, the answer is yes and no. Okay. And that's correct. Somebody just messaged in, hey, I think you could probably simplify that. And that is correct. And that's what I'm going to show you. We can combine some of these together, but we can't combine all of them together. So what we have to look for are things with the same variable and the same exponent. Same variable, same exponent. Now, you'll notice that in each one of these, they have the same variable. Well, that means I can combine it all together, right? No. The other thing that we need is the same exponent. So I notice here, and I'm going to use purple for x cubed, that I have another x cubed over here, but I don't have an x cubed anywhere else. So I can combine only these two together, 2x cubed and 9x cubed. They're both positive numbers. And so 9 and 2 add together to give me 11. So I can combine those two to give me 11x cubed. Okay, if you're taking notes, make sure you're copying that down as we kind of step through the rationale. All right, next, and I'll put a bubble here. I'm going to bubble around my 3x squared. Do I have any other x squareds? I do. I've got one right here. All right, I've got a positive 3 and a positive 7. And they both have x squareds. So I can add those two together. Plus 10x squared. All right. Now, I'm going to do a circle around here and here. So here I have an x and here I have an x. So I can combine those because both of those have an exponent of 1. So negative 5x to the first and 2x to the first. So negative 5 and 2 I can combine. Negative 5 plus 2 is negative 3. So I'm able to simplify this whole thing down to 11x cubed plus 10x squared minus 3x. All right. Let's look at another one. What about this number? All right. I've got 4y squared minus 3x squared plus 2. That 2 is kind of doesn't look too good, so I'm going to write it like that. Minus 7x cubed plus 4y minus 6x squared plus 8y squared. All right. Well, let's go through here. We're going to look for same variable and this word and is very important. Same exponent. Okay. The word and means both have to be true. It can't just be the same variable. So these three all have x, but I can't necessarily combine those three together. And then these three all have y, but I can't necessarily combine all of them together either. Now the same exponent. Well, look, I've got 1, 2, 3 twos, right? 3 twos for exponents. Can I combine all of those? No, because they don't all have the same variable. Some of them do. Oh, here's another 2 over there. So we have to be very careful when we combine these. It has to be the same variable and the same exponent. And remember, we're combining like terms. We're combining things that we can add together, okay? So let's look at this first one, 4y squared. Well, I'm looking for another y squared. Nope, 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 close, but nope, nope, yes. All right. I've got a positive 4y squared and a positive 8y squared. So I've got a 12y squared. Very good. All right. Now I've got a y here. So let me do a circle around that. Do I have any other y's? I have no other y's, so I can't combine that one with anything. So I'm just going to put a plus 4y. Now I'm going to move on to my x's. All right, here I've got a negative x squared. I don't have an x squared here. I don't have an x squared here, but I do have an x squared here. A negative 3x squared and a negative 6x squared. So if I combine those, I get a negative 9x squared. All right, moving along here, I have a 2, which a lot of times we just call a constant. What do we mean by constant? It has no variable association. It's not being multiplied by any variable. Okay? All right, had somebody asked me, do they both have to be negative? I'm assuming you're um, talking about these negatives in front of there. Is that what you're talking about? Go ahead and message me again. Okay. So, and this is where I made them negative when I first wrote out the problem. Let me do this. So when I wrote it out originally, 5 or 4y squared minus 3x squared plus 2 minus 7x cubed plus 4y minus 6y squared plus 8y squared. Okay, so the fact that this is negative 3 and this is negative 6, that doesn't mean we can or cannot combine them. We do not care what number is being multiplied. All we care about, sorry, this is an x squared. All we care about is this an x squared? If it is an x squared, then I combine the two numbers in front of it, negative 3 minus 6. So negative 9. If one of these if this one happened to be plus, then we would have, plus 3 or just positive 3 minus 6, and that would be negative 3. If they both happen to be positive, this would be positive 9. If the 3 was negative, but the 6 was positive, yep, then this would be positive 3. Does that answer your question? Okay. Yeah, we don't care about the number in front of it. Now, we'll talk about this tomorrow, but the number in front of it has a name. It's called a coefficient. Okay? And we're combining the coefficient, right? We're combining the 4 with the 8, the negative 3 with the negative 6. All right, so where were we? Negative 9x squared. Good. Now what you'll notice is that we have a 2 and a negative x cubed that can't combine to anything. So we're just going to leave them alone. And that's our answer right there. You cannot simplify that any further. All right. Let me double check something here on the syllabus. Okay. All right. So what we want to do is now we want to look at factors. Okay, we looked at terms. Now we're going to kind of look at factors. Remember, factors are things we multiply. Okay, factors are things we multiply. So I'm going to give you 3x squared plus 2x minus x squared. So the first thing we're going to do is we're going to see, can we combine any terms? Okay, can we combine any like terms? So terms are things that we add, and like terms have to have the same variable and the same exponent. Okay, so here I see that my 3x squared and my negative x squared have the same exponent. So I can combine that. 3 and a negative 1. And that would give me a 2x squared plus 2x. All right, everybody with me so far? Good. So what we want to do here is identify the factors inside each term. Okay, so here is my first term. Here is my second term. I'm adding these two things together. Therefore, these boxes represent the terms. So this is a term, and this is a term. Now, inside those terms, we have factors, okay? So let me show you here. The factors here are 2 and x, because I'm multiplying 2 times x. Now let's look over here. We have 2 times x squared. And x squared are two things being multiplied, x and x. So my factors in my first term are 2 times x times x. My factors in my second term are 2 times x. Everybody see that? All right, so let's do a practice one. 3x to the third minus 2x squared plus 4x to the third plus 7x squared. No, plus 8x squared. Let's do plus 8x squared. And let's not do 3 here. Let's do 6. Wow, that looks bad now. I'm going to rewrite that. Sorry about that. I'm going to redo this. Sorry. Let's do 4x cubed minus 2x squared plus 6x cubed plus 8x squared. All right. So the first thing I want to do here is combine my like terms. Okay. So I am going to, I've got a 4x cubed. All right. Now here is where, this is a good example. I'm going to show you, here's where I'm going to change this to a, instead of having a minus here, I'm going to change this to a plus negative. Okay, that's the same thing. Remember, our definition of subtraction said that if I subtract two things, that's the same thing as plus the opposite. Okay, so there's my first term. Here's my second term. Here's my third term. Here's my fourth term. Okay, I have 4 terms. Can I combine any of those? I sure can. I can combine the 4x cubed and the 6x cubed. That gives me 10x cubed. And I can combine the negative x squared and the 8x squared. And that gives me a positive 6x squared. Okay? Go ahead and message me if that didn't make sense or if you want me to rework that. But now we went from having 4 terms down to 2 terms. All right. And inside those terms, I have factors. All right. We want to break this down to our prime factors, okay? So here we have almost like a factor tree. 10 times x cubed. 10 can be broken down into 2 times 5. Those are my factors. And x cubed is just x, x, x. Okay? Now here, 6x squared, that is 6 times x squared. My 6 is 2 times 3, and my x squared is x, x. Okay? Everybody good so far? Right. Go ahead and message me if you have a question or if something doesn't make sense. All right, now that we understand within these expressions, you guys now understand what terms are and you understand what factors are, right? Things that we're adding, things that we're multiplying, okay? Now, there are something called common factors, okay? And you've probably heard of the phrase greatest common factor. Okay, if you look at two numbers, you can find the number, the biggest number that you can divide into both numbers. That's your greatest common factor. Well, here we have common factors. And what we mean by common, we mean exactly that, exactly the same. So if I look at the factors of these two terms, I'm going to circle the things that they have in common, okay? They both have a 2 in common. And they both have 2 x's in common. However, only one of them has a 5 and only one of them has a 3. And then there's an extra x, right? This has 3 x's, this has 2. So they only have 2 in common. This one has an extra one. Okay? So in algebra, one of the things that I can do is I can factor out common factors. Okay? Factor out common factors. What does that mean? That means that I can pull out a 2 and I can pull out 2 x's. And then what I'm left with in this term, if I pull those things out, I'm left with a 5x plus over here, I'm just left with a 3. Okay? So 2xx is 2x squared, then times the quantity 5x plus 3. Okay, so what just happened here? Well, I pulled out of the 10x cubed plus 6x squared, I pulled out the common factors 2x and x. So that's what you see here, 2x squared times, because I pulled that out of the 10x cubed, plus, and then I pulled the 2x squared out of the 6x squared. Now watch what happens if I distribute this back in. If I take these factors here and I distribute it back in, okay? 2x squared times 5x plus 2x squared times 3, okay? 2 times x squared times 5. 2 times 5 is 10. X squared times x is x to the third plus 2 times 3 is 6, x squared. We're right back to our original expression, okay? That's where factors in terms and understanding those differences are super important. Okay? All right. Anybody need me to leave this up while you take notes, or can we move on? Let me know if you need to see it. All right. So now what I'm going to do is give you another problem here. Let's do 5 times the quantity x plus 4 minus 7. All right. Are there any like terms that I can combine here? Well, here's one. If I change this -7 to a +7, plus, and then here's my -7. All right. Here's a term, and here's a term. Can I combine those? Yes or no? See your answers in the chat. Can I combine those two terms? Oh, somebody said yes, I can. Anybody else? Yes or no? Just one brave person willing to put their question or their answer out there. All right, at face value, I cannot combine these. I cannot. Why? Because um, 5 is being multiplied by this expression. I have an x in here. I don't have any x's here. There's really no way to combine these two. Now, if we simplify, so let's go back to our original problem. 5 times x plus 4 minus 7. If I do 5 times x, this becomes 5x. And then if I do 5 times 4, this becomes 20. And now that I've multiplied that through, I can drop those parentheses, minus 7. Now you'll see that I can combine the 20 and the -7. And that combines to be 5x plus 13. So sometimes we need to simplify an expression to see if we can combine it. When you have parentheses like this, sometimes we may need to multiply things in there so that we can see those terms as we need to see them. Okay? All right, so I'm going to give you another one like this for you guys to work. So let's do go ahead and work that one on your own. I'll give you a couple of seconds and then I'm going to start working it. Or if you just want to watch me do it, you can do that too. And if you get to the answer and want to write it out, feel free. All right. So here, I've got some parentheses. So I'm going to simplify this by distributing through. So 6 times 2x is 12x. 6 times positive 4 is positive 24. Now I have -7 times 3x. That's negative 21x. And -7 times positive 7, negative 49. All right, so now I've got um, individual terms. So I'm gonna change everything to addition because I think it's a little bit easier to look at things that way. So 12x plus 24 plus negative 21x plus negative 49. Okay, I changed everything to addition. So now I have terms that I can look at to see if I can combine. Okay, and so I know that I can combine my 24 and my negative 49. And I know I can combine my 12x and my negative 21x. So negative 21x and 12x combines. I got to think about that one. That gives me, let me see here. Negative 9x, and then 24, negative 49. That gives me negative 25. All right. And that is that combined. Negative 9x minus 25. All right. So we've done quite a lot today. We have combined like terms. We've multiplied things out and combined like terms. And we have factored out by finding the common factor. So make sure all that's in your notes. That is it for today. So if you guys want to go ahead and jump off, we are done. You guys have a wonderful evening.